So now we are turning to the second part of this seminar. It's dealing with impacts and responses, but it's also ending with a panel, an invited panel here that will reflect and react to what the panelists have heard. And that will be part of this second section of the seminar. So let's get started this now, and I will turn over to Dr. Philip Williamson, University of East Anglia. He's actually also working for the UK Natural Environmental Research Council and has in his earlier life worked for Plymouth Marine Laboratory, but also for IGBP here in Stockholm, actually across the road from here, I have learned. So you are very welcome, Phil, and the floor is yours. I can just instruct you with one thing before I let you go, and that is if you want to use the cursor, you can simply move it up there.
Thank you.
And then we'll show that. Okay. And you will then, of course, speak on the impacts and responses regarding the marine ecosystem. So please, you have the floor.
Thank you very much, and thank you for the invitation, and great opportunity to be here. And my talk actually might be a little bit shorter than some of the others, so there might be opportunities for discussions and questions at the end. But for the opening slide, you've probably seen that before. It has been shown actually in one of the introductory presentations. It's the front cover of the summary for policymakers. But there's also a back cover to the summary for policymakers that shows equatorial seas. And my thesis or argument, to simplify a little bit, you've heard an awful lot about, excellent, I really appreciated having the talks and the additional background and what we heard about the cryosphere side of things. Now I'm talking about the ocean, but not just the cold part, the warm part as well. And the real, and it's pretty high level stuff, but it's one ocean, one global ocean, and it's everything in between, and it's from the poles to the equator to the coastal seas to the bottom, and the whole ocean is changing as a result of climate change. And to some extent, only to some extent, the greatest changes that we've heard about in the physical, in the cryosphere, in the polar regions and the cold parts of the world, actually having the greatest influence in the warmer seas. Sea level rise, but also the effective temperature rise there for some species is greatest, even though the temperature rise might not be as great in absolute terms. But we heard about all the heat that's going into the ocean compared within the atmosphere. It's still rather ironic that we have our climate and our weather records are primarily on the atmospheric records, and meteorology is all about the atmosphere, but it's in the ocean really, which is the driver of the climate system over long time periods. Okay, so what's happening in the ocean? The temperature increase, that organisms respond, they have optimum temperatures, and their distribution around the world is determined by other things as well, but primarily by the different temperature regimes that organisms, that physiology is best adapted to. So if temperature changes, then distributions changes, physiology, metabolism, a whole lot of other things change. But in addition to the direct effect of temperature on marine organisms, we've got the sea level rise, the physical things for affecting the coast. Deoxygenation we haven't heard about, and I'm not going into any great detail, but that's a consequence of a temperature change, stratification, change of circulation means that there is less oxygen reaching the middle of the ocean. And for some species and organisms, that's a pretty important factor. Okay, we've got the storms and the heat waves, the day-to-day, month-to-month weather events affect organisms. It's the temperature extremes that actually do the damage rather than the mean average temperature. So we need to know the temperature extremes. Nutrient supplies there, that's important for the phytoplankton, but then it builds up the food chain. I'll cover that in a little bit later on. And we also just had, I think it was mentioned, I'm not going into any great detail on ocean acidification, but we know without a doubt that extra carbon dioxide going into the ocean causes chemical changes that has effects for some of the organisms that live there. Okay, so I can still say, well, so what? You know, why should we care about these things? Well, and we care about them because the life in the ocean provides the ecosystem services and the benefits to humankind. And in the red circles, where's the special Stockholm laser stick here? If you look I actually prefer to use a stick, if I may, I do like modern technology. I realized I came to Sweden, you don't need any money here at all. It's all modern technology, but I like to have a pointer because for some of my slides, they've got embedded pictures on. And if you click on the picture, you go to a website. And I don't want to do that in front of you all to show where I got my pictures from. But these ones are probably quite safe. But these here, there is a city there, and there is a house on a bit of rock there. So those are the people living there, and what it's really all about. Ocean changes, life in the ocean changes, but it's people that matter. Now, we haven't got the last speaker today, which is unfortunate, but I hope in the discussion we might cover some of the aspects of the consequences for people and society. Okay, so last time I was here, 1993, I think I had one visit in between time, but then that was when I was over the road with International Geosphere Biosphere program. I did have the privilege of meeting with Bolin and working with him. I think we've got one paper together. It's a pretty trivial one, but we've got one paper together I'm very proud of. But for the 30 years ago, 26 years ago, as mentioned in the introductory question was, well, is this actually real? Is it happening? Do we have the evidence? And that for the first IPCC report, then the question was, well, have we got the observations to prove it? And so that there was room for some doubt. But now there's absolutely no doubt at all that the changes really are happening. And this is only half a figure from the summary for policymakers. Problem with the IPCC, I mean, it's a great organization, but sometimes even in the summary for policymakers, there's a lot of information there, there's a lot of technical detail, and it actually sort of needs someone to break it down, explain everything that's going on. This is only half a picture from the summary for policymakers. I probably could spend half an hour dealing with just this one, but I'll break it down a little bit, make it a little bit simpler for you. Just this top part of that picture, this is what you've heard about. This was the previous hour. The observed changes in ocean physics, temperature, oxygen, ocean pH, sea ice, sea level. Those are observations of either increase, decrease, or within those regions that there might be changes in two directions. It doesn't mean say that they cancel each other out, but within a region, different sub-regional effects may be occurring. Now, the evidence showing that there has been changes that can be attributed to greenhouse gases, that is being driven by the change in atmospheric composition, the confidence limits that IPCC are very keen on, that there's no doubt about it, that high level confidence and medium confidence that these changes are happening. But for the physical changes and really the direction, it depends on how you describe the terms, whether you're saying ocean pH, I mean, ocean pH is falling, but that's actually, for organisms, that's sort of bad news. But in this graph, there isn't good news, bad news. It's just saying there are changes occurring, and some are going up, some are going down. But that's the physics. Those are the changes, right? When we go on to the next slide for the biology, for the impacts for the ecosystems, now we can say, are these changes favoring the organisms, or are they making them less abundant, affecting their distribution in negative ways? And it's a little bit sort of anthropomorphic to say, are they liking it or not? But on the whole, that the red is negative, bad news, that the changes are having deleterious effects on species and organisms. And although there are a couple of blue ones indicating that actually the temperature increase or the other changes are benefiting, there are more organisms as a result. Those are very much in the minority. And we've got 30 of these comparisons that show that it's going in the wrong way as far as those organisms are concerned. And although there aren't quite so many at the higher level of confidence, that putting all that information together clearly shows that that's the big picture, and that's sort of concern. But again, what the consequences for human society, and this would have been something that our last speaker would have talked about a little bit in greater detail, we have the impacts of those ocean ecosystem changes on fisheries, tourism, habitat services, shipping, and the rest of those. And for shipping, that's sort of good news. That's the good news one, that you can cross the Arctic without getting stuck in the ice, unless you deliberately want to get stuck in the ice, that some people might want to do so. However, on the whole, it is bad news for people, it's bad news for for the organisms that live there. But this, up until now, this has been the evidence of the observed. And if you do read the summary for policymakers, and I hope you do, it's structured a little bit differently from the chapter by chapter structure of the main report. The main report deals with mountains, it deals with particular topics like sea level rise or different extreme events. But within the summary for policymakers, it looks at the observed, what's our level of information and confidence in the things that have happened. It looks at projections, and it looks at the governance and the responses. So that's the way that the SBM is structured. Okay, so much for the observed. Now going on to the comparison of what has happened and what is likely to happen or may happen. And here we have the ocean ecosystems. And for the low emissions that we've heard about, the RCP 2.6, it's pretty gray in the middle. No major changes seem to be happening in terms of net primary production. The green on the left is it's a model of the present state of the amount of primary production, the basic plant growth in the upper ocean surface, and then the other graphs are the two scenarios. Now that actually hides some factors there that are pretty important, and that is species composition and biodiversity. There might be changes in which species are where because of the warming, because of the temperature effect, that don't come up in terms of primary production. Primary production is in carbon per meter squared per year, but it might be that you get different sizes of organisms, different species, and that has been observed, and that is likely to continue, that the species that live in the tropical waters are actually, not surprisingly, moving poleward in both directions. Their distributions are changing, even though there might not be much in the way of gross primary production. But when you get to the RCP 8.5, the high emissions, which is what we want to avoid, then there are changes in primary production, and particularly one can say, well, is this a potential, is it good news? But this purple color for, if we've got an ice-free Arctic, then not surprisingly, there's going to be a percentage change. And if you didn't have any production there at all, because it's covered by ice, or you only had the algae that were able to grow in the ice, if you've got an ice-free Arctic in the summer, you do get more plant growth in those regions. So that's not a great surprise. But okay, that's the primary production. The secondary production, if we go up the food chain here, then the effects become more pronounced as one goes up the trophic levels, and the smaller animals that are feeding on the plants, the effect of the climate change is actually amplified as one goes up the food chain. And so here, previously, there wasn't much indication on the left-hand side for the low emissions. Now we're getting the purples at the top, some orange there. The high emissions, this overwhelming picture here of increased orange colors, and that is really emphasized on the next one, which looks at the top predators, or the things that we catch and the things that are important to people, and that's fish or fishery catch potential. Doesn't necessarily mean that that is what we will catch, but it's the catch potential, what is available there. And then if one looks at the maximum for the fisheries, the left-hand side, as before, is the simulated present, low emissions and high emissions. And then it becomes much more apparent that the orange areas, the bad news is all in the tropical areas, and potentially around Norway, Sweden, Scandinavia, there's a bit of a mixture. It doesn't necessarily mean that we will get that higher. It is a projection. It does depend on the species being able to move, not being overfished, and being in the right place. And to some extent, these are a little bit over-optimistic in that when there's been high fishing pressure and then perhaps there's some protection measure, it is expected that a fish stock will recover within 5 or 10 years, and actually it doesn't. It takes 20 or 50 years. So it takes quite a time for the fish and the populations to adjust and to move into new areas, because fish, they've got homes to go to, they have spawning grounds where they've been going to for thousands of years and where they go back to. Therefore, you provide new areas that are potentially suitable, but it's not necessarily that they will all find their way there and live happily ever after until they're caught. This is another way of presenting the information on the projections. Whether you've seen these graphs at all. They're called burning embers, and there's two temperature scales. On the right-hand side, we've got the sea surface temperature in degrees compared to pre-industrial. On the left-hand side, it's also a temperature scale, but it's the air temperature. So it's the difference between the air temperature on that side and the sea temperature there. So if we're talking in most of the IPCC projections are in terms of the air temperature on the left-hand side rather than the sea surface temperature on the right-hand side. And although and there's not much difference, but just to be aware of that. But clearly that sea surface temperature, as one goes deeper in the water, there's less of a change. But the organisms that live closest to the surface, warm water corals on the left-hand side, and I'll come to those in a moment. But actually, I'll use the warm water corals to explain a little bit more about what those graphs actually, how they're constructed and what they mean. And if you didn't get the idea, the level at the top here is if we have the high emissions, those are the temperatures up there. If you have the low emissions, you can keep in this range. But for warm water corals, they are already in trouble. And that's shown by the shading there, that if it's the dark reds, if it's the purples, they are already being greatly affected by, and I'm sure you all know this because it's been in news the last 2 or 3 years, that warm water corals are already in big trouble, coral bleaching events, and that the time for recovery of corals, and a coral reef can recover bleaching, said, well, perhaps that's a natural event. We just sort of didn't know that it was happening before. But if it only happened every 20 or 30 or 50 years, coral reefs can grow back. They can look much the same as what they were. But if the frequency of bleaching is occurring, and instead of every 10 or 20 years, every 5 or 10 years, and ocean acidification is then slowing their rate of growth back again, so that the ocean acidification that has already happened has slowed coral growth by about 10%. The ocean acidification over the next 20 years could slow it by a further 10%. So you've got the double whammy. And for corals, they're also subject to a whole lot of other human pollution pressures. They're also affected by sea level rise. So it's one of the most sensitive organisms. It isn't a particularly new finding for the SROC report. It was in the 1.5 report. But the realization that the difference between 1.5 and 2 degrees centigrade might not seem very much, but that is potentially sort of life and death. Doesn't mean they're all going to be extinct or all completely eliminated. There will be some survivors somewhere. Biology is like that, but we will lose a lot of what we've got. Now, within the SROC report, there is discussion on coral gardening and whether we can sort of almost cultivate and sort of save them in coral zoos. And that there are advances in that technique and process, but they'll only work if we can keep the temperatures down at that lower level. Going back to all the other burning embers there, most of these are the coastal ones. On the big global maps, I showed the global ocean. Here we've got coastal ecosystems, and just pick out 3 there and their sensitivities to the future climate change. And the 3 seagrass meadows, salt marshes, and mangrove forests, they have got the label of blue carbon because they're particularly important for storing carbon in coastal regions, and they have been indicated as in countries' national determined contributions of climate change. How can they mitigate climate change? And one idea is, well, if they can protect and restore the blue carbon habitats, then these habitats have an accumulation of carbon, unlike sort of other areas where most of the time it's carbon in, carbon out. Because the sediments in these coastal areas are anoxic, then they're at present storing carbon. But on a per unit area basis, their carbon storage is greater than forests and greater than a whole lot of other comparable ecosystems. But the problem is that there's not quite enough area of them, and we're losing these habitats. We've got to save them, to protect those habitats and keep them intact. But the scope for actually increasing carbon uptake on a global scale through enhancing and restoring these habitats is pretty limited. And one issue here is the rate of future change, and that if if sea level and the temperature rise is relatively gradual, and if these habitats are in a very natural condition and that they can migrate and move inland, and if sediment can build up, they actually can increase this extra carbon dioxide by responding to the carbon dioxide as a fertilizer. If there's lots of sediment and they can move up, they can cope with the rising sea level. But if you have a situation where you've got depleted sediment coming down rivers because of damming or changes in water flow, you've lost some of that. If you have rising sea level that is relatively rapid, if you have increased storminess, you have erosion removing that carbon-rich layer, then you have the degassing and the release of the carbon dioxide. So although that's a little bit simplistic, it does sort of indicate, well, how things, unfortunately, seems to be the message of the afternoon, that we haven't got very much good news to tell you. I think I'm going to might be one or two more. Right, okay, this just reinforces, you've already seen messages like that saying, keep the temperatures down, act now, and avoid the worst. So I'm not quite sure. I've got it in quotation marks. It's somewhere in the IPCC report. I don't think that was taken out at the final stage. It's somewhere in there. But I'm sure that is, I don't need to give that, to tell that to this particular audience. Thank you very much indeed. Thank you. And if we have time, I'm happy to take a question or two.
Yes, please. Thank you very much, Phil. You covered a lot of ground here, or rather sea, during the 20 minutes. But we have time for some additional questions. Yes, please.
Yes, thanks for nice illustrations. But I have also a question concerning your scales, because you made a number of nice diagrams where you show impacts on the ecosystems, and those impacts at the scale, positive or negative. And then I think I got your point. It was on the perspectives of the organism. But in my understanding, an ecosystem consists of many organisms. My simple question to you, how do you distinguish those different organisms, and what are the priorities for different type of organisms in those ecosystems? Okay. Oh, sorry.
Repeat the question.
If I can summarize the question, it was sort of your question is a very valid one, that there is a great deal of oversimplification there, going from species to individual organisms to species to ecosystems, and that in the diagrams there were from the summary for policymakers. It is a summary, and one's got to go into the detail. There is information on particular groups and things, but it's necessary to have some oversimplification. I won't try and defend all of those, but I certainly recognize the point you're trying to make, and if I'm not answering your question, but I'm agreeing with you.
Okay, excellent. Any other questions? Yes, Jonas.
Yes, you showed that there was especially in the 8.5 scenario, there was a strong decrease of productivity, primary productivity across the tropical oceans here. So what's the primary cause of that? Is it acidification, temperature rise, or maybe is it increased stratification, so decreased upwelling on nutrients? Or
my understanding is it's increased stratification, but also for tropical regions, that if the temperature rises by a degree or two, there aren't species that sort of thrive in waters that are that warm. That the species have evolved to be in the present day conditions in the tropics, not with the extra couple of degrees centigrade. So that the decrease in productivity is just based on the physiological optimum, but also compounded by the decrease in nutrients and stratification effects. But there's a lot of information that goes into those models. I'm familiar with some of them. Some of them are like the CMIP of model into comparison, so they might not all have the same factors within them. Acidification is not the main issue for the primary production. The acidification is likely to change species composition and some of the calcifiers, but it's not, and there's not strong evidence for acidification causing the decrease. And if the acidification were having effects, more likely to be in the tropical, in the cold water areas. And yeah.
Okay, thank you very much. I think we should move on then. And I think we can save further question if we have some time left at the end here. So next speaker is Dr. Miriam Jackson. She is from the Water Resources and Energy Directorate in Norway, but that's not her original nationality, I think. But anyway, this is an important area. You are mostly working on the mountain regions and impacts in mountain regions, including glaciers and freshwater supply. So we are very happy to have you here. So please, you have the floor to speak on the cryosphere impacts and responses actually on the cryosphere, including freshwater with a focus on mountain regions. Thank you.
Okay, thank you very much for the introduction. I will be talking quite a lot about the cryosphere as well, and a little bit on freshwater and impacts. So my name is Miriam Jackson. I was a lead author in Chapter 2 of the report, which was high mountain areas. I live and work in Oslo, the Norwegian Water Resources and Energy Directorate. And for people who don't know about this, I tell them that in Norway, water and energy are pretty much the same, because a lot of energy comes from hydropower, so these things go together. So I'm going to be first looking at the different cryosphere components. We've already heard quite a bit about snow cover and permafrost, so I'll not go into that. Lake and river ice was also is also an important part of the cryosphere, was in the report. Unfortunately, there's not actually much literature about changes in lake and river ice specific to mountain areas, so we did try and look at that, but we weren't able to find much literature. So that leaves me with glaciers, and as I'm a glaciologist, I'll be talking quite a lot about glaciers. And this is a nice graphic. It's not actually produced by the IPCC. I forgot to put on the attribution. And this basically shows the population of the world. So all these little figures represent 100 million people. And if we look at the third and the fourth lines, the white figures there, this shows you the, can't get the cursor to come on. This shows you the people who will be affected, who live downstream from the Hindu Kush Himalaya, and will be affected by changes in the cryosphere in high mountain Asia. So it's a huge part of the world's population. And also there's other people who live downstream from other mountain areas who aren't shown specifically here, who are also affected by these changes in the cryosphere. The top line, the light blue, is actually those that live in low-lying coastal zones. It's also about the same number of people who live in the mountain areas. So for many people, we think these changes are quite distant, or they're very important in terms of sea level rise, but also for all the many millions of people living in mountain areas and downstream from mountain areas. These are very important changes. So we've heard a lot about the cryosphere, a lot about the ocean, but in between mountains and the ocean, we have land, and lots of people living there, and lots of changes that are happening and are going to happen. So these are the areas that we looked at in the report, and they cover a large proportion of the Earth. The white is actually the ice sheets. I know a lot of it's white, but they're very white. So Greenland and Antarctica are the ice sheets, and they've already been discussed thoroughly. And the brown areas are the mountain areas, and they cover quite a large part of the world. And in many, not all, but many of these mountain areas are glaciers. Some of the glaciers are small, so you can't actually see them on this scale, but this is something that is basically affecting every continent. And for Chapter 2, we actually divided these mountain regions into defined the boundaries, just to make it easier to look at the different regions and the changes taking place. And this shows also the permafrost. We've heard about the permafrost already. And this, in some areas of the world, is very important. It's not actually very visible. I think this is one of the things that also really gets people's attention with glaciers. We talk a lot about climate change and about the temperature's gone up, 1 degree. If you say that in the middle of winter, people are like, well, it's cold. Global warming, what on earth is it? It's cold today. And we talk about increased carbon dioxide, but again, it's, how many people here have thought, ooh, there's a lot of carbon dioxide today. You don't think about that. Permafrost as well, it's, there's some dramatic pictures we were shown, but generally it's not very visible. Whereas glaciers are a very visible sign of climate change. And I think that's one of reasons, apart from the importance of the runoff, there's so much focus on them. It's just you can really look and see, this was a glacier 20 years ago or 50 years ago, this is a glacier now, something's happening. So this is, I think, one reason there's so much focus on them. In these different regions, we've shown the altitude of the glaciers and also the 0 degree temperature line. And in some regions, you can see that the 0 degree temperature line is actually very close to where the glaciers are. So if you get a small increase in temperature, that's going to have a big effect in one region. Oh, wait a minute, do I get the cursor up? How do I do this? do I press or, or do I?
Let's see, have you found it? Where it is? Yes, the red dot was turned off here for some reason. Just click on the little that one, the pen.
Oh, okay.
No?
And click on that and laser pointer.
Laser pointer.
Does that work? Oh, there we go. Yeah. Okay. So you can see in many areas of the world, for example, low latitudes, there is actually glaciers in northern South America, in Africa, in Indonesia, and these are very susceptible to changes in temperature. There's also many in, for example, the Caucasus, and even in the southern Andes, you know, the glaciers, they are basically below the 0 degree line. So any changes, I mean, they're already being affected. Also in high mountain Asia, you actually find that glaciers are very high. They're not going to be affected to the same extent, but there's still many of them are close to the 0 degree line. Also, there's a lot of people living downstream. So basically it's, you know, even though the changes aren't quite as big, there's so many people affected by them that they're very important. We already had these figures from Rob, ice loss from glaciers between 2006 and 2015. So although Antarctica is much bigger than Greenland, actually the ice loss from Greenland is going a lot faster than from Antarctica over the past decade. And also for high mountain areas, the volume of glaciers in the world outside of the ice sheets is very small. If they all melted, you know, these smaller glaciers are almost meaningless. But the thing is, they are changing very fast right now. And for me, actually, these figures, you know, 220 gigatons, it's very, you know, how big's a gigaton? It's quite hard to imagine. I've given this talk a couple of times in Norway. And I don't know if you heard about something called Mannen in Norway. This was a large part of a mountain that was unstable. And there's been a lot of monitoring of it. And there's also another part that was smaller, it's called Veslemannen. So Mannen is a man, Veslemannen is the little man. Veslemannen was very unstable and it was monitored and people kept seeing, the instruments kept showing motion and people were evacuated and then they were sent back again. And eventually in September, just before this report was released, so Veslemannen collapsed. And it was very dramatic, this huge part of the mountain collapsed. And if you compare the volume of Veslemannen with the volume of ice loss from mountain glaciers, it's as though we lose Veslemannen once every 7 seconds. So go back and watch this video and imagine that happening every 7 seconds. That's how much ice we're losing from the mountain glaciers. Here's another figure that shows, it's also from the report from chapter 2. It shows a lot of information, but it's worth looking at. So for each region of the world, we looked at ice loss over the last few decades. Some regions of the world, we don't actually have many decades of records. This is another problem with looking at changes in the cryosphere. The records actually don't go very far back in many places. So the blue is looking at sea level. You can see that Alaska is really the important one here. Also the southern Andes and high mountain Asia. However, if you just look at the red bar, this is the mass loss from glaciers in terms of kilograms per meter per year. In some regions, it's really going very fast, especially here in Scandinavia, Iceland, in fact, in pretty much many regions, it's going very fast. And you can see the graphs here. High mountain Asia, as I said, is actually not losing ice mass as much as some other regions. So it's a fairly obvious statement here. 1 meter water equivalent per year is the average. So some areas are more, some areas are less, you know, no shit. But it's just, you know, you have to remember then that some areas the changes are very dramatic. And in other areas such as high mountain Asia, the changes aren't as dramatic, but the consequences are very big just because there's so many people living downstream. I mean, just look more closely then at the southern Andes, Central Europe, many of the European Alps and the Caucasus. And here the changes are really happening very fast. This is looking at, again, it's also from the report, looking at the projected change. This is in the mean winter snow water equivalent. So comparing a 20-year period, 86 to 2005, with the near future and the far future. And we have the changes in the mean snow water equivalent, also the winter air temperature and the summer air temperature. And of course, for glaciers, it's really the summer air temperature that's important. If the average temperature in the winter is -10 and you increase it to -8, doesn't really have that much effect. If you increase it from +8 to +10, you're going to get a lot more melting. So the summer air temperature is really important. And again, we've also heard that, there is this average temperature increase globally, but it does vary a lot from region to region. It's not consistent. And some regions, it's a lot bigger. So one region is the Arctic. We're seeing a lot more temperature increase in the Arctic in the last few decades than the global average. And we're also seeing a lot bigger temperature increases in mountain areas than in low-lying areas. So again, when you think about the average, there's regions that are having these changes happening a lot faster and responding a lot faster. And again, just looking at the European Alps, I think the main thing to look at here is the difference between the low emission scenario and the high emission scenario. So the low emissions is the blue color, the high emissions is the red color. And the darker shading is the far future, so 2080 to the end of the century. And in the near future, there's not a big difference between the two scenarios. Obviously, in the high emission scenario, things happen faster, more intense, but not that much difference. But if you look at 2080 to 2099, there's a huge difference between the two emission scenarios. And again, looking at each individual region, then projections of glacier loss. So this is the global average here, excluding Antarctic and Greenland, because they're sort of special cases. So just looking at individual areas, and this is looking at 3 different scenarios. So 2.6, low emissions, 4.5, middle, and then the high emission scenario. And for many regions of the world, especially under the high emission scenario, by the end of the century, there's going to be very little glacier mass left, or possibly none. So especially again, Central Europe, low latitude, so Africa, Indonesia, New Zealand, the Caucasus, these areas will really see the effects, many other areas as well. There's a few things in the report called FAQs. This is a frequently asked question. It's just something that's not all the sort of the IPCC gibberish of high confidence, low confidence, just trying to explain some of the concepts. So the IPCC reports aren't meant to be a textbook, but there's some bits where it's really worth it just to explain some concepts more. And actually, Rob already showed a part of this figure. And this was looking at what happens to the water downstream as the glaciers melt. And this is something called peak water. So as the glacier melts, will you get more water or less water downstream? And the answer is both. First, you get more water, and then you get to a turning point called peak water, and after that, you get less water. And this, again, this varies from region to region. Even within a region, it varies. It can vary from one valley to the next. And this is perhaps a little hard for some people to understand, that the glaciers are melting, the glaciers getting smaller, but the runoff's getting bigger. But then at some point, the runoff will get smaller. So you get these changes, and it's not even a change in the same direction. You do get this turning point called peak water. And this is the whole figure from the FAQ, and this is sort of looking over several decades of what happens as the glacier melts. We get more and more runoff, peak water, and then we get less runoff. Eventually, the glacier's not there. If we look at that on a yearly time scale, about the time you get peak water, you're getting a lot more water than you were previously. This could be good. Sometimes more water is better. If you have more water for irrigation, it's better. More water for hydropower could be better. Or it could be a problem. It could be too much water. Hydropower can't always use more water. It might not be irrigation, it might just be flooding and causing big problems. And also, if you look at the daily time scale, again, you get more intense variations as the runoff increases. And then if you look at the end of this period, when the glacier is melted, on a sunny day, you're not going to get any runoff from the glacier. And this is where the runoff is very good. If you have a hot, dry summer, it's very important for agriculture. It's very important for hydropower to get this extra runoff from the glaciers. And once the glaciers have gone, you're not going to get that. And if we look at when peak water is going to happen, the red line shows 2019. that's this year, we can see for many areas we're actually past peak water already. So we've had the increase in runoff, and now there's going to be less and less runoff. And this is for Scandinavia. See, in Scandinavia, we still have a couple of decades to go. High mountain Asia, Iceland. So we're not there yet, but it's coming in the next 10 or 20 years for many of these regions. So what can we do about this? This is one solution. We heard about coral gardening. This is glacier gardening. So grow your own glacier. This is called an ice stupa. A stupa is a Buddhist kind of monument, and this is one made of ice. Not just because it looks pretty, but it's a way of storing the water. As I said, if the glaciers are getting smaller, have melted, you don't get that runoff in the summer or in the spring and the summer when you need it for irrigation. So you have to make your own glacier. So this is one solution that they've done in northern India, and it has worked very well. It's also, you are then depending that you still have freezing temperatures, that you can get the water and freeze it and store it this way. It's also very labor intensive and quite costly. So it could work in some regions, but it's not an ideal solution everywhere. So we get changes in river runoff. This does affect many things, including irrigation. A lot of focus has been on, 1,000 million people living downstream the Hindu Kush Himalayas. And many of them are living so far away, they're not going to see, these big changes in the cryosphere. There are millions of people who live very close to the mountains. They will, but the people living very far away won't. But there is something like, I think it's 100 million farmers downstream of the Himalayas who are getting 10% of the water from glacier runoff. So this, for those people, it is very important. For some of them, it's going to be a lot more water than 10%. And it might not be very important to us, but a lot of these areas are quite vulnerable. And, when things go badly, when your agriculture isn't the same as it was before, then people start moving and possibly to another country, another continent, and then there's problems. So these things have a lot of sort of knock-on effects. And also, as I said, it's, more water isn't necessarily better. More water could be more flooding. Another thing that we actually haven't really had time to cover in this seminar is also hazards. There's a lot of glacier hazards. As glaciers retreat, you get either ice dam lakes or moraine dam lakes being formed. And these can also suddenly burst out, and then you suddenly have many years worth of water coming in the course of a few days. There's also problems with water quality. We have legacy pollutants, so a lot of things that we used before have been banned because they were dangerous, they were poisonous. And in some areas, especially high mountain Asia, especially Central Europe, where populations quite close to the glaciers, these things, the pollutants went to the atmosphere, came down locally as snow on the glacier, became glacier ice. And now as they're melting faster and faster, you're getting these legacy pollutants, things that have been banned because they're so dangerous, you're getting increased concentrations of them. There's also natural occurrences of these. As the glaciers are melting faster, there's more erosion from the glacier. So things like mercury, for example, are again coming into the downstream system. There's changes in sediment. This has effects on many things. It has effects on ecosystems. It has effects on hydropower. And there's also changes in temperature. Again, it goes both ways. In some areas, the water in the rivers is being colder because there's more glacier runoff, so the temperature decreases. In some areas, the rivers are warmer because the temperature is warmer. And for some different ecosystems, this is good. For others, this is bad. And I also mentioned hydropower. This is actually a very important source of energy and source of income for many mountain regions, which often are quite marginal. They're not always the richest regions. So the hydropower is very important. These photos are actually from Svartisen in northern Norway. I was there with some students this summer, and you can really see that there's this big change in the drop of the reservoir. And if you have a decrease in runoff to a reservoir, if it's a reservoir, it's not as bad. You can sort of cope with changes. However, in Asia, many other places, a lot of the hydropower is run of river. So then you can't cope as much with these changes in runoff. And I also said again, it's you could get more water. This is good. There's actually been instances in Norway we have glacial lake outburst floods. Suddenly you're putting, 20, even up to 40 cubic million meters of water into a reservoir. If they have space for that, that's great. If you don't have space for it, that's a problem. You're going to have to release water beforehand. You could have problems with your dam. So even in cases where you do have reservoirs, changing the amount of water into the reservoir is going to cause problems. And there's also problems in seasonality. There might be the same amount of water over the course of the year, but if you're getting, instead of getting snow in the winter, you're getting rain in the winter, this is going to cause a problem. You're not getting the water when you need it. So even if the amount of water changes the same, the seasonality can really mess things up. This is sort of an attempt to show the impacts then that I've discussed. And this is, again, the different regions of the world, all the different mountain regions. And you probably can't actually read anything on here, but the second square down is water availability. So you can see in several areas of the world, we do have this problem with water availability that is changing. It does look like in some areas you don't get this problem, that you don't see these impacts. However, these are observed impacts, so these are documented. In many areas, for example, North Asia, low latitude areas, we just didn't have the literature. And this is actually only medium confidence or high confidence. Something that we had that was low confidence didn't make it on here. And this is a problem. Then we know these changes are happening, but they're just not documented. So we can say that this is what we've seen in certain parts of the world, that we know these changes are taking place, are documented. And other parts of the world, there's probably going to be similar impacts. We might not have studies that show it yet. We might not have literature that documents these changes, but if they're happening many other places, they're going to be happening in other places as well. And this figures actually was then taken up and used in the summary for policymakers. It's the other part of the figure that Phil showed, which is now changed beyond all recognition. But I think this is just a nicer way of showing where these changes have been observed already, and just the range of the changes that you're seeing, the physical changes in the cryosphere, the changes in the ecosystems, which is the green. And again, just because some of these middle columns, the green's not marked off, it doesn't mean the changes aren't taking place. It means they're not observed. And the blue showing the human systems that are affected. So we have agriculture, I talked about a little bit about irrigation. We have hydropower, but we also have many things like tourism. So tourism, the main effects are going to be on hazards, but also just things in terms of, how much water is in a river, if you're going to cross the river, if you're going to do things like rafting in a river, availability of drinking water. So as I say, we can see many of these changes taking place over the world, and other places, they're not documented, but they're probably happening anyway. So thank you very much for your attention. This is this picture, and the first picture actually from Bhutan. So this is, I worked in Bhutan for several years setting up mass balance measurements. Again, this is one area where there was very little documentation. There was no glacier measurements before we started doing them in 2012. And many of these areas, they might not have the measured changes in the literature available, but they're going to see the effects a lot sooner than we're going to see them in Europe. Thank you.
Thank you very much. Very informative. We have time for a couple of questions, actually. Anyone would like to comment or ask a question? Miriam. Maybe you are getting tired this late of the day. If not, thank you once more. It may be possible actually to come back a little later here before we close with some questions that you have discovered that you eventually wanted to put anyway. So thank you very much. That means that we should change the scenery here a little. So now it's time for the panel to assemble here. And I suggest that you take one chair each here and line up. Sit down. And I will put the microphone in the middle of the table. It's a real pleasure to invite the panelists here to this final round discussions, but reactions and to what we just have heard here. And to the left here, to the right from your side actually, is Helene Ågren, the Swedish ambassador for the oceans, affiliated with the Ministry of Foreign Affairs in Sweden. An old colleague of mine. I'm very happy that you're here. And in the middle is Jannik Kihlberg, a climate reporter. The climate reporter, no, the climate reporter, of course, of the Swedish newspaper Dagens Nyheter. And to the left from your side is Dr. Tom Arnbom, Senior Advisor, Arctic and Marine Issues from WWF Sweden. I think it's a very qualified panel, and I was actually going to find a paper that I had prepared here. Thank you. The idea is that this should not be really a panel discussion, but rather reactions and comments from the three panelists here. But I thought that I could start by putting you on the track by asking some leading questions here, and then you could choose to respond or not. Let's make that fairly quick, and then I will give the floor to each of you to expand on issues connected to this that you feel important actually to highlight even further. Is that okay? Fine. In that case, I would like to ask you this question. What is your immediate reaction to what you just have heard? Not the signal, actually, but the whole event today. All of these very informative presentations about the ocean and the cryosphere. Helene, do you have any immediate reaction that you would like to convey? I think that you could take it off there and that you can circulate it.
First of all, I would like to thank the organizers for arranging this event on this important report, but also the previous presentation, very interesting and informative presentations. It's difficult to have any other reaction than we are in deep trouble. We knew that from before, but this is confirming previous reports that we are heading towards changes and a world that looks very different than the world we see today. And it will have huge impact on not only biodiversity and ecosystems, but also on societies. Behind all these graphs and figures, there are real people that will be affected in coastal communities, in mountains region, etc. And it will be probably quite costly to try to avoid the most severe impacts, but it will be even more costly to not do it.
Yes, pass it on to Jannik, please.
Well, I have to agree. Thank you very much. It's been very interesting, and I can just agree with previous speaker. But I also think it's not really depressing, but it's also a confirmation of what we actually see happening around us. And therefore, I know my readers are increasingly interested in these subjects, but they also are craving for facts. They love facts. And I also think here in Sweden, you could really see an increase in interest last year. But I think it's good to have the whole picture, which you get in this report. Is very interesting to put it all together, and you sometimes you get some figures here and there, but you get an overall picture which is quite scary, but also confirmation. I look at one person here that I know who's been, at least in Sweden, actually our highest peak has melted down. So I think people are aware of what's happening, and it's interesting to have the facts behind what you see.
Tom, please.
Yes. So I read many reports in my life, and I think this last IPCC report is the best one because it's clear, it's dead on, and it's serious, and you get the urgency. And I think that also how it's been presented. I really appreciate that the researchers come forward and say this is the truth. Because normally, as a researcher, you try to hide it somewhere between the lines, but here it was dead on. And I saw the press conference; it was very good. And even cut off some of the journalists trying to say ambivalent if it was climate change or not. No, it is climate change happening. And this is not happening in the future, it's happening now. So I think I really thank you for this report because it makes a big difference and it makes the argument much easier. But at the same time realize the policymakers, the decision makers are not there. They are so far behind in making and understanding this is urgent. And I can say, I mean, from my own point of view, I can't say it's WWF's point of view, but if you look on the politicians in Sweden, when they talk about small things here and there. They don't understand this is important now. We need to go do actions now because we will earn money by doing now and not wait 10 years or 20 years to do something. Because it's now we had the time. There's a window here, which I think we should grip and take it. And I think the politicians, decision makers, that's not only politicians, I talk about the industry and also ourselves had to think it's time for action. I think I stop there, I can come back later on.
Yes, I will say that that as a follow-up question to this, it's interesting to hear your reaction on how does this relate to the wider question of urgency to raise ambition of climate action and respond to demands for such actions that we have seen over the last couple of years. You, I think, sort of started to introduce that issue.
Yeah, I mean, you can look at different levels. You have the global level, but I think I will leave out the politics there because there's lots of things happening on different directions with politics just now, which is pretty sad, I think. But if you look on the Swedish level, I can go for that. It's easy for me because I'm not part of the government. But I think there is a climate law in Sweden which has to be filled with something. We don't know what's going to be filled with. We know some, which might be. But I think it's not going to be enough. And I think that's because it is a slow-moving government, really, because you can't. That's how the structure is. You can't move forward quickly sometimes. But I think the ones on higher level, the needs to understand why not put together some kind of climate crisis commission between all of the parties and do something in big action. Because now it's more politics trying to do and it's not so it goes back to the way to and make much we should dare to do decisions.
Do you think actually, as a comment to that, and maybe you also can comment on that, that information actually about what's happening in the cryosphere with the Antarctica, with the Greenland ice sheet, with the sea ice, is that useful in actually then even more promoting the need for taking that sort of crisis-oriented action?
Yes, I think it's very important, especially if we've been talking a lot about the cryosphere here, but let's say what the implication will be for the tropics. I mean, if the coral reef goes, not all of them, but say 80% of the coral reef goes, that means a few 100 million people will lose their daily living. So that's where are they going to get the proteins from then? It's in the report there might be up to 1 billion people moving because of the sea level rise. So today's migration will be nothing compared to what's going to happen in the future. So if you look at the cost effective to do something now, it's just, I would be stupid if I wouldn't invest in it now and wait to invest it. It's just, so that's why I see the urgency, really.
Please, Janke.
Well, I'm sort of an outsider being a journalist, so I think my best reference is what I see in our readers' interest, and they are, as I said, extremely interested in this subject. I think we could probably fill the whole paper with climate issues, actually. But I also, what you say and what you said, I think but nowadays you can always check how many people read the articles. So what we see is, I was at the UN climate summit a couple of weeks ago, but people that they always read about Greta. So they do like the sciences, but they also want Greta, and it's really, I think there you find very high sort of pressure for the politicians to kind of lean against, because there is a big willingness. I think you can see that in those demonstrations and what people actually are doing today, and this growing movement with it, which is very, very interesting, I think, and how fast it has gone. So that I think today you have a great acceptance for quite hard rules or anything.
May I ask you as a follow-up to that, can you see any, or have you seen any level of interest in getting this more comprehensive climate information from the general public, the readers, for example?
I can only talk about our readers, but they are, yes. And I think it's really increasing, and they have always have quite a big interest and they send mails with quite constructive questions. And can you write more about this? But they also want to see some solutions. I think not only the problems, that we also get a lot of things. Can you please tell us what we shall do? How can I do something? What can the politicians do? So, and the interest is really huge right now, I think.
So one side is the threat, another thing, the other side is response and action, actually, to respond to those threats. Helen, I used the more English variety, Helen, rather than Helen. But Helen, please, would you also like to comment on this?
Well, when we talk about urgency, I think we need to look at the 3 reports that have been presented this year. It's the 1.5 degree report makes it clear that there is a big difference in effects if you're talking about 1.5 degree temperature increase and 2 degrees, not to talk about the other scenarios where we are moving towards 3 or 4 degrees or more. So, and the more we wait to reduce emissions, of course, the more we need to invest in adaptation measures. So looking at where people live, we have a lot of people living in coastal areas, and a lot of infrastructure is threatened, and we need to reinforce and create barriers to increased water flows from the ocean and from the mountains, etc., more heavy rainfalls, and we can go on. So constructed infrastructure like buildings, roads, harbors, etc., will need heavy investments. And I think we need to do that even if we are increasing pace in reducing emissions. So it's not a question about that, but it will be more costly if we wait with mitigation measures.
Thank you. Yes, definitely so. But now, given if there is this strong movement and in the world among many groups of people, but also there seems to be a strong desire to get more information what's actually happening, both as pointed out by when it comes to how the development looks like and what it can do about it. Is really IPCC living up to those expectations? I have myself, if I may be a little personal, thought that the SPMs are not an ideal publication to show to a general audience, and maybe not even to the policymakers that you think of when writing it. But it would be interesting to hear your reactions to, is IPCC really good at communicating those very important findings? And if not, what could one do about it? Would you like to start?
Yeah, I could start. I mean, the report is I mean, at least the summary for policymakers is readable, but it's a bit of heavy reading to interpret in every sentence these likeliness or very likely or moderate or whatever. So it's of course we need, when we are informing the general public, of course, we need intermediate, someone translating also and making the report relevant. What does this mean for my daily life? If I live in high mountains or in coastal areas, etc. So communication is actually a special competence, and we need to acknowledge that, and we need to also support organizations that are actually doing good work on this. To reach out, I think we need good journalists, we need good work from academic institutions, from the civil society, and NGOs are doing a fantastic job also to reach out with research results and suggestions to policies, etc. So we need all of those, of course.
Janneke, would you like to comment on this as well?
Oh, yes.
Sure.
What do you want to say? No, yeah, actually, I think they're doing quite a good job. And they're, as you say, the summary for policymakers are readable. They're not the sexiest reading, but on the same time, you have to balance between the scientific facts. So maybe journalists or organizations should do the peeping part, sort of. But so I do appreciate it. And I must say, I think the last year, there was 3 special reports that has been delivered. They've been excellent and very useful for us. And of course, you need help. I used to call Marco so he can tell me what I should do, because you need some meat on the bone. As you said, they've been on the spot, and it's been very valuable that they already have an angle, sort of. It's a lot easier to grasp what they're saying. So I think they've been extremely useful for media, and they live quite long. I mean, we're still referring to the 1.5 degree report. So yeah, I think they're
okay.
Very
nice.
good.
Very nice hearing, Tom.
Yes, I can say we were well aware of the report a long time ago, and we've been thinking how we're going to present or back it up. So first you start the cryosphere. Who knows what a cryosphere is? So we started thinking about that. We made an animation which we could send out on social media to show people what a cryosphere is as a start. So we started with that, how to disinfect this heavy report into simple messages. Then you lose, of course, some of the messaging, because sounds a bit harder, but then we try to show more of the impact. So then you talk, okay, it will affect so many people. It will affect the commercial fisheries. So we had to think about that. So the impact, we're talking more about money, and we talk about people. And also, of course, as a World Wildlife Foundation, we need to talk about animals too, but we talk about ecosystems, which are backing up people. So food production, competition of water. There will be, as Miriam talked about, energy, and who's going to have agriculture. If you got less water, are you going to drink it, or are you going to use for agriculture? Homes and rights. That's the next step, which is going to be harder. And those things we are thinking the next step, how to do and how to present it so people understand it. So we are then trying to the way, how do you bring the next 2-3 steps? But sometimes we miss it, but we lose also a message because we are losing the fine-tuning things because we sound so harder than it is.
Those were very encouraging words. I think that we do think that the SPMs actually serve a role here, and it's important to have them. But it seems also from what you all 3 have said that it's also important to have some intermediary agents here that could actually expand and present the results in a more edible version than that makes it more robust and concrete to people to read these findings. Is that a fair summary of what you have said?
Yes, Morris. I would say, it's hard for IPCC to be, they're presenting a report which is basic facts for policymakers. They are not really supposed to tell everyone in the world what this is all about. That's a different mandate. Maybe you can get that mandate, but that's a big difference. Who should do that?
For those of us who have been involved in IPCC, we have all heard Saudi Arabia arguing at the final sessions on adopting the SPM or synthesis report. Anyway, that was very interesting. I have a few maybe more specific questions here that we could maybe quickly I could quickly pass on here, and then we could have a sort of, you could then complement then what we have discussed so far with highlighting what you think would be important for the future. One is, do you think that political decision makers are sufficiently aware of what's happening in the cryosphere and polar regions? By the way, actually about this campaign about cryosphere, is that the Twitter campaign that some people was exposed to actually explaining cryosphere?
Yes, I think so.
Yeah. I hope it helped actually, because that was badly needed. But what do you say about this actually, about are people sufficiently informed about what's happening, and especially political decisions making, what's happening with the oceans and the cryosphere?
I think some people are definitely well aware of it, but then the reality in the way they live, they have so many other problems that to take care of, unemployment and things, so which could pop up and something media pops up and they have to drop it. So it's a bit tricky. So you have to be pretty strong to go for the urgency for the climate change, because the reality for a politician is 4 years.
Awareness is not enough, simply. Jannike?
I find it a bit hard to comment on that, but I could say that they should be, because the information is there, but I can't really answer if they have sort of taken it to them.
What do you say, Helen?
Well, I definitely think there is awareness, and there are steps taken to take long-term responsibility, even though it's far too little and far too slow. So all the processes on setting goals, sometimes very ambitious goals to reduce emissions. The Swedish government, for example, has set itself on a cross-party agreement to reduce emissions to net zero emissions by 2045. But then when it comes to implementing the measures that make us really reach that target, it's another issue. So, but then again, I mean, there are also important to come up with, I'm looking at Ola, who is have been working also at the ministry. We have to find cost-effective solutions. So, and there we have maybe a gap in researchers actually engaging in climate science. We have chemists, geologists, etc., but we don't have enough economics, I think, that are really engaged in trying to find cost-effective solutions and contributing to the debate also. It was highlighted by Stern and Oswald a couple of days ago. And I think we also need all these multidisciplinary contributions to come up, and all stakeholders involved to come up with the right solutions.
Thank you. I think that I have had two concepts, or rather two observations about what's happening in the cryosphere and in polar regions, that I think that many political decisions makers that I have been talking to over the years have difficult to comprehend. And that is one, that many of the processes are irreversible once they start. And of course that emission of greenhouse gases and carbon dioxide is also irreversible in itself, actually. So it's not only that you get the climate you get is the climate you will have for a very long time on, but the scary is that there are then impact processes in the cryosphere that are irreversible, will make us end up in a completely different place. The other one is also, even if it's pointed out very often, is that things happen so much faster. in the cryosphere, especially in polar regions than elsewhere. So, someone showed this slide. I don't know who it was then. That when we speak about 2 degrees, we speak about 5 to 6 degrees in the Arctic. When we speak about 4 degrees, we speak about 10 degrees in the Arctic. And I found those 2 specific things have difficulties in actually get stuck there in the minds of many political systems, because that have, of course, far-reaching repercussions that it happens that way. I think I should invite you to a final round of comments now, where you can highlight whatever we have not discussed so far and that you think are important, or revisit some of the questions here to further highlight some opinions that you have about that. Would you like to start, Helena, since you are sitting with a microphone ready to speak?
Yeah. When we talk about climate change and ocean change, the top priority must be to of course, with different policy measures to reduce emissions. But as I said, we also need to work with adaptation, but also try to increase resilience of societies and of ecosystems if possible. So we need to work at both national level to do our homework, but also internationally to support. If you look at the ones who are hit the hardest by these changes, it's small island developing states, tropical regions, people depending on fisheries for food security and livelihoods. So we need to work with overseas development cooperation, with innovative financing solutions to trigger all the investments that are needed. And we need to work with global processes to increase awareness and mobilize the different stakeholders that needs to be involved. But also, when we talk about resilience, we need to look at the whole set of problems that are facing the health of the ocean. So climate change is the most severe one, but we also have really difficult problems with overfishing. We are subsidizing overcapacity, illegal, unregulated, unreported fisheries. We are polluting our waters, so no one can have escaped from seeing all the effects of plastics in our ocean, but that's only the visible problem. So we also have all the flow of nutrients from land to sea, and chemicals, not the least, and different pharmaceuticals we are eating, and eventually it will end up in the ocean. So when we talk about increasing resilience, we also have to reduce other type of stressors to increase resilience to climate change. So here we also need massive efforts at national level and internationally. Of course, global cooperation to move towards a more circular economy, reducing waste, reducing the outflow of chemicals, nutrients, and other marine litter, etc.
Quite a lot of job ahead then.
Yes.
Please, yeah.
I don't really. I think I should talk a bit more about what I can see. I think what I'm a bit afraid of is that we will see an increased polarization, sort of. Someone who's really want to change the politics, and those like the Gilets jaunes. We get a lot of. I'm afraid we can have quite a lot of fights in the future. Maybe a bit of what we see in Chile right now in Santiago, and so I think it would be very, very. There's a lot of things we can do, but it's also very, very important to have this just transition to keep everyone on board. So I think that's maybe a main interest, because I can see that in my mail also. Some of those climate deniers that actually were gone around 4 years ago, they are popping up like little zombies. So and you can see it's hardening, and some of them are younger, a lot of it on the right wing. So I think the just transition is really, really important here.
Thank you. Yes, please, Tom.
Yes, totally agree, especially with Helena, and you said many of things I wouldn't say, so I won't repeat that. But I think one thing to walk onto awareness is scenarios. So people just make public scenarios, how it will look like if you do this, how will it end up? And I think that would be, we should do it in a popular way, which sounds horrible maybe, but it's a way to make it awareness for decision making. If you don't do this, where are you going to end up? This is how it's going to cost. That's one way to do it. Another way could be, we should all the time connect biodiversity with climate change, because it's all connected, and you can't survive either with the other. So biodiversity is also one of the big thing. And as you probably noticed, the change in climate change to climate crisis. If it's, you say, also biodiversity into mass extinction. So those words could change the way of people thinking, but I don't like that, but it's the way how things work sometimes. And for the Swedish government, I think you should put much more effort into SIDA. So the foreign aid would go to mitigate and also, as you say, take care of the stressors on the ocean. Because climate change is one stressor, as you said, many other. If you can do something about other stressors, it might be easier to for the ocean to hold out a bit longer, at least. EU, I don't know what to do with EU. It's a bit tricky. Sweden cannot always change the EU. Yes, but the way Sweden could do to find like-minded countries and take a step ahead together, because you can, if you strategic, choose which country can we work together in different parts of the world which have similar agenda and dare to go forward, show difference. That could be one way also to do it. Because with the SDG 14, for example, Sweden and Fiji, they make a pretty big impact when that went through, and it was different kind of alliance which was not really tested here before, and it worked very well. The Fiji is still going on, but Sweden lost behind.
Yes, that's right.
But I think I'll stop there. But one thing which was brought up here, which we just mentioned a bit, indigenous people, was mentioned in one of the talks, and I think they are the ones going to be hit worse. And when they hit really badly, they lose the culture, and that's gone. That's irreversible when that's gone. And that's sometimes I feel that's more horrible than losing an animal species.
Yeah. Thank you very much for those wise words that you have all expressed here. Yes, only on what Sweden should do. I mean, there is this high ambition coalition. I wonder what happened to that. That would really have to be revitalized again, I think. But all of those areas that are commented on must, of course, be taken very seriously in the future. There's definitely no doubt about that. So I would like to thank you, but I want you to stay for a couple of more minutes, because I would like to turn to, we have 5 minutes more to go, you see, and we had a question submitted before. I don't know if that's that person in particular is still with us, but we can at least address the question. Okay. But we could start with this one. Maybe this is, I think this is directed towards Rob de Ponto, as a matter of fact. It is it's saying that it was difficult to see what sort of impact that would be from sea level rise, or what it would be in the Baltic Sea. Do we have anything further information about how the Baltic Sea will be impacted? Where you could find specific figures on that. But let me say that there was actually a fairly big scientific studies in Sweden some years ago on that issue. I think Marco probably have more information about that. That actually analyze very carefully impacts on the Baltic Sea. But please, Bobby.
Okay, so that's a great case in point as to why you have to look regionally and ultimately locally at something like sea level rise, because of the ice sheet that was here until less than 15,000 years ago. It's gone, and the land is still coming up. And there's very strong sea level lowering because of that. So the relative sea level is going down because the land comes up faster than the sea level is rising. And I think the numbers are, it's been a while since I've looked at those maps because that's not the component of sea level rise I really study, but it's approaching, I want to say, approaching maybe a centimeter per year in the northern part of the Baltic. The land is coming up. So the rates of sea level rise that we're talking about today are on the order of 3.5 millimeters per year. So we're talking millimeters to multiple millimeters per year, one versus the other. So this part of the world is going to fare better in the short term in terms of sea level rise. But one thing I didn't mention specifically is that once you move beyond, let's say, 2100, the rates of sea level rise, and this is something new to the SROC, we do talk about this, that are possible, particularly because of these processes in Antarctica, could produce rates of sea level rise that are multi-centimeters per year. So if you have a little bit longer timescale perspective, even this part of the world that is relatively protected today will be impacted. In terms of specifically looking for information, you can try to squint at there's a figure that in chapter 4 that actually shows the map of relative sea level change for RCP 2.6 versus 4.5, and you can see what is going on in the Baltic. But we've actually provided information about the recurrence of these extreme events as supplementary information, and the data are actually available. So a person could look at a tide gauge record that's been made available through the SROC that is closest to home and actually look at the numbers.
Okay, excellent. Thank you very much. There are two more questions, I understand. Are they short and fairly succinct?
Well, we'll see.
Yes, let's try them. Try one first.
Okay, we have a question from Christopher Bostrom. What could be the next steps for the Nordic region? Do you think we need a Nordic Scandinavian single voice in COP25, or should we go with the national agendas? And if yes, what would this be? What are the most important implications for the Nordic countries from the SROC?
I don't know if you had any specific person in mind here, but I think Helene might be the best since he's really speaking about what Sweden should do here. If you have any quick response to his question about Nordic cooperation and action.
Well, actually, when it comes to climate and ocean, we have a recently established working group within the Nordic Council of Ministers looking into effects and solutions and policy in our closest region. And also the Nordic environment ministers will meet later this week and discuss this issue also. And we are cooperating also, not within the Council of Ministers, but several Nordic countries are involved in the international partnership, the Ocean Pathway, where we are working together with other parties to the Climate Change Convention to raise awareness about climate and ocean, to look at where the linkages are within the climate in the implementation and follow up of the Paris Agreement and the Climate Convention, and how we best could work with the existing tools and mechanisms to raise this issue. So there are cooperation, but of course you could always do more.
I can actually comment more specifically on the COP because I'm partly involved in that. The organization that I usually work with, the International Cryosphere Climate Initiative, we have been entrusted by the chair of COP Chile to organize the Chilean pavilion at COP25, and that pavilion will be entirely devoted to the cryosphere. So we are organizing that program, but in this context we are cooperating very much with the Nordic Council of Ministers, and we will have sort of exchange between the pavilion and the Nordic pavilion that, as far as I remember, always has been at COPs. And So it's very timely that we are discussing actually here now the cryosphere and the oceans, and exactly what then the Chileans will bring to us through their pavilion there. And I think it's quite nice to be also involved, to have a little say on how that can be organized. But it's still open for support and cooperation. If you have any brilliant ideas about what to present, please let me know so we can see. But I mean, we Nordic countries have had long and standing cooperation on climate change and also in these areas. We have not mentioned other organizations that are important, for example, the Arctic Council, but that's another story. I don't think we have time. Well, we are 3 minutes actually past the time set out in the program, so I think we have to skip the very last question. I hope the webcast viewers have been happy with actually getting 2 questions responded to here. So, but by saying that, I would like to thank the panel. It was a very interesting discussion and many interesting views conveyed here, but I would also like to thank all the speakers here, and thank you for the work that you have also put into the IPCC report, and it's extremely qualified work, and I think that your presentations here have been also extremely informative actually, and being eye openers in a way that you get that additional information that was not there in the SPM, and get a much fuller picture of what was happening and is happening and will happen in the oceans and the cryosphere. So finally, of course, I would also like to thank the audience here. So after having thanked everyone, I would also advise that we give an applause to the panel and the speakers for their very good job. Okay, session closed.